Welcome to Quick MCAT Lessons, where I try to explain MCAT topics in 10 minutes or less. Today we have a quick lesson on G-protein coupled receptors, also known as GPCRs. GPCRs are a massive family of membrane receptors that detect molecules outside the cell and trigger internal signal transduction pathways. They're involved in everything from vision and smell to neurotransmission and hormone response, and they are extremely high yield. Structurally, GPCRs span the membrane 7 times. We call this a 7-transmembrane domain. When a signaling molecule or a ligand binds to the receptor on the outside of the cell, it causes a conformational change in the receptor. This change activates a membrane protein inside of the membrane. This is called a G protein, and it can be monomeric, which means it only has one subunit, or more commonly, it can be heterotrimeric, which means it's made up of 3 subunits. The 3 subunits are alpha, beta, and gamma. Now, G proteins are called G proteins because they can bind to both GDP and GTP, which is guanosine diphosphate and guanosine triphosphate, respectively. In the inactive state, the alpha subunit is bound to the GDP, which is the guanosine diphosphate. But upon activation, the GDP is switched for GTP, which is guanosine triphosphate. And the alpha subunit dissociates from the beta-gamma complex to interact with downstream effectors. Since there are so many GPCRs, there are so many downstream effectors, but some common ones include adenylyl cyclase. And what this does is it converts ATP to cyclic AMP. Cyclic AMP is a secondary messenger that activates protein kinase A, which leads to a bunch of things. Another one is phospholipase C. This generates IP3 and DAG. These are both important for calcium signaling and for protein kinase C activation. And eventually, the GTP is hydrolyzed back to GDP. The subunits reassemble and the signal is turned off. Now, you don't need to know the exact specifics of the downstream targets, but just the basics of what I talked about should be fine. You should know that GPCRs are involved in signal amplification. One ligand can activate many molecules, and they work through secondary messenger systems like cyclic AMP, IP3, and DAG. And many drugs and hormones, including epinephrine, glucagon, and histamine, work through these GPCRs. And just to sum up, GPCRs are a central hub for transmitting signals from the outside to the inside of the cell. That's it for today.